Okay, so say that one more time. Two divisions. Long works for anything. Synthetic only works when you're dividing by x plus or minus a number. When you all did long division, back with numbers, I'm going to do one. Say I said take 13 divided by 279. What's the first thing you do? How many times does 13 go into 27, which would be twice, which would be 26. Okay, so you write the number at the top. How do you get the number that goes below the 27? What do? You take the 2 on top times the 13 out front, and you get 26. Then what do? Then you subtract and get 1, and you drop the next number down. Okay. I go again. 13 goes into 19 once, which will leave me then. It's down here. I put 13. I change my sign to subtract, which would be 6. What did you do with the 6? I don't want to go to a decimal. Thank you. R6 was before you knew fractions. That's what we taught you, R6. Well, you learned or it was 6/13. Okay, we are going to do the exact same thing except do the variables. Exact same process. Just have to do it with a bunch of variables. Okay. However, a couple things you have to watch out when you are first writing it down. Now, why did I divide it that long? The top I have over there isn't that long. Well, it's kind of like if I gave you the number, if I write 125 and I tell you that stands for 10,025, how can that stand for 10,025? 10,025 is written this way. I just wrote 125. What did I leave out? I left out the zeros that are placeholders. Okay, you can't do that. It's not the same number. Same thing happens here. Up there I have x to the 5th. What power should come next? X to the 4th. You have to have every power represented, and so as we do the division, everything lines up. So this isn't going to work out, and I'm not going to end up with my numbers lined up in the right places if I don't leave zeros for missing terms. So you have to notice as you're writing this down, yep, I've got x to the 5th. If there's no x to the 4th up there, I leave a 0 x to the 4th to hold that spot. You'll see why in a minute when we do the division. Okay, I don't have an x cubed, so I have to leave another 0. I do have an x squared, so I'll write my minus 2x squared. Then do I put my minus 24? Yeah, I need a 0x because I'm still missing the first term, and then a minus 24. So suddenly our problem got a lot longer. Sorry, but there's a pattern here, so it's going to go pretty quick once we get rolling here. Okay, everything, when you're doing long division, everything, the first term is the key to everything. That right there is your key. You're asking yourself, what do I need to take times x to make it become x to the 5th? X times what is x to the 5th? Wouldn't I need x to the 4th? I want that mic too. So I would need that. And you can check yourself. If you take x to the 4th times the x out front, it better be that. Okay, how did you all get to 26 down here? You took the 2 on top times the 13 out front. We do the same thing. Whatever you put on top, you take it times everything out front. You multiply it times both terms. So you're going to have x to the 5th minus 2x to the 4th. Now, what did we do after we wrote the 26? We subtracted. Number one mistake on long division. Subtracted. But in our case, we have multiple terms. You have to subtract them all. So change all the signs, not just the first one. Okay. Those first ones will always then cancel. The x to the 5ths are gone. So now you have 0x to the 4th plus 2x to the 4th. What's that add up to be? 2x to the 4th. And you drop the next number down. And you do it again. What times x makes 2x to the fourth? 2x to the third. You have to put a plus or minus between them. It would be a positive 2x to the third, so you'll write plus 2x to the third. So now you're going to take that term times everything out front. 2x to the third times x will make, 2x to the fourth. 2x cubed times negative 2. Yeah. Okay, and once again, do what? Subtract. Change your signs. Change your signs, change your signs, change your signs. So that's a minus. Now that's a plus. The 2x to the fourths are gone. What do I have left? 4x to the third. Drop the next term down. And do it again. Because x times what makes 4x cubed? Well, it would have to be a 4 with an x squared then. Take 4x squared times everything out front. Whoops, minus, sorry. 8x squared. Change your signs again. The 4x cubes are gone. And you're down to 6x squared. Am I done yet? I got to drop the 0x. Last block they would say, well, why can't we just skip the 0x? It won't come out right if you do. So, what times x makes 6x squared? We're getting down to easier ones. 6x times x would make 6x squared. And it's positive, so I write plus. So when I take that times everything out front, what will I get? Minus 12x. And the pattern says I do what? I subtract and change the signs. The 6x squared cancel, and I have left, adding down, that's 12x. And finally, I get to drop the last number. This is it. Last time, hot dog. What times x makes 12x? 12. Yeah, so, okay, plus 12. Can I quit and not finish? Whoops. There's the bottom of the problem. So I would need to subtract, I guess I shouldn't say subtract yet, sorry. 12 times x minus 2 is 12x minus 24. Is that good that that's the exact same thing? Yeah, that's really good. You like that. That's the best thing. If that comes out identical, because when I subtract and change my signs, the whole thing adds up to be 0. That means I have no remainder. So there's my answer to my division. That entirely new polynomial came out of it when I divide. Boy, howdy, was that good fun? You want one with 10 terms in it, right? I don't want to grade it. It takes too long. I wouldn't even give you this one this long on the class. It takes too long. Okay. So now, what, however, happens, suppose this hadn't come out to be 0. Suppose you had come out with a 7 down here. So what do you 7 over what? X minus 2. And you have to, every term's added or subtracted, so if there were a remainder, you would go plus 7 over x minus 2. You would add that on the end if you have a remainder. Sometimes you will, sometimes you won't. So that's all you do in that. Okay, so y'all want to do 52 problems like that. Why do we care? Why would anybody use long division? It is not a form of suicide. Believe it or not, when we want, you remember the asymptotes from hyperbolas, the dotted lines, the graphs approach as they go to infinity? When we are doing other kinds of graphs, and they may have, you can have horizontal asymptotes, or excuse me, vertical asymptotes. You use long division to figure out where slant asymptotes are, diagonal asymptotes are at. That's one of the uses of it. That's the most common. That's the place I use it the most frequently. We come back and do long division to find out where those would be at. So that's one use of it, but don't get excited about that. That's not in your future until pre-calc. I'm sure you have to do long division. I'm sure they make you do it in college algebra. I don't know if they have you find asymptotes in college algebra, but I know you have to do long division. Okay, so who wants to learn how to solve this in once you learn how, you can do this in like 30 seconds. Same problem. It's going to take me a little longer than 30 seconds to teach it to you because I got to explain what's happening. But what do you all think of when you hear the word synthetic? Man-made, artificial, fake. I think of it as fake division. Okay? We're going to do the same problem, but when you do synthetic division, you take out all the variables. You just do the numbers. So, and y'all aren't going to believe me till I prove it to you. I'm going to do this exact same problem, all I'm going to do with synthetic. Okay. To do synthetic, it's going to take you 3 lines of paper. That's it. On the first line, you're going to have a little box. You have to put a number in the box. It's really key that you put the right number in the box. If you put the wrong number in the box, the whole thing's going to blow up. So, the most important number up there in that division problem is what you're dividing by. We're dividing by x minus 2. And remember I said this only works if it's x plus a number or x minus a number. If it was 3x minus 2, you wouldn't do this. You actually can do it, but you have to do it with fractions, and it would be horrible. I would do long division before I would do this with fractions. So I don't teach it that you should do it unless it's just x plus or minus a number. Okay, the number that goes in the box comes from what you have right here on the bottom. If that is x minus 2, you put the opposite sign. You put a positive 2 in the box. The opposite sign. That's mission critical. So if it was x plus 5, what would you put in the box? Negative 5. Okay. Now, out to the side of the box, you're going to write down all the coefficients off the variables. Okay, but you have to remember to leave zeros for the missing variables. So it's like if we took what was inside this long division problem. Inside this long division problem, we had a 1, 0, 0, negative 2, 0, negative 24. That's what you're doing here. When you look at this problem, you go, I have a 1x to the 5th. I don't have an x to the 4th. I don't have an x to the 3rd. I have a negative 2 for x to the 2nd. I don't have an x to the 1st. And I have a negative 24. You're literally taking the coefficients off all the variables. Just take the numbers, dump the x's. It's amazing. Okay, you're going to need to leave yourself a line. You're going to put some numbers on this line, and then we're going to add. That's all we're going to do. Yes, I said we're doing division, but we're going to add. It's weird. I don't know who dreamed this up, but it's just really awesome. It's like, how does this work? Okay. Usually I have 2 mistakes on synthetic division. We either get the wrong number in the box, or we forget how to start. To start, you take whatever the first number is, and you just write it down below the line. That's it. You just drop that number. Don't add it, multiply it, anything. You just put the first number down below the line. Okay. After this point, you do the same thing for all, but we're going to fill every column in with a number and add down. After that point, anything you write below the line, you multiply it times the box. So what's 1 times 2? 2. And you're going to go put the answer in the next column. 1 times 2 is 2. Add down. It's 2. So times it by the box. So 2 times 2 is 4. It goes over to the next column. And 0 plus 4 is 4. So take it times the box, which will be an 8. Add will be 6. 6 times 2 is 12. Add is 12. 12 times 2 is 24, and add. If you get 0, it means you have no remainder. You love to see zeros, because it means you won't have a remainder when you get done. Now, have you ever seen the numbers 1, 2, 4, 6, 12 anywhere on this board? It's the answer. Look at the top of this long division. 1, 2, 4, 6, 12 are the coefficients. Yeah. Pretty amazing. Okay, so then if you hadn't done the long division, so this is your answer, but the question is 1x to what power? How do I know what power to start writing my answer with? It's 1 less than what you said. If you started, this problem was x to the 5th, that'll be 1 less. So that's 1x to the 4th, and you just keep going down. 2x cubed plus 4x squared plus 6x plus 12. And there's the answer. Oh, thank you.